First layer woes, last layer woes, and layer woes in between. All this and more, Print Fix Friday, episode 128. Let's get into it. Hey guys, welcome back to the channel where we help you get your printers printing with purpose. Print Fix Friday is all about helping you getting your machines back up and running. And you can slide into those DMs on all the social medias, or you can, of course, email us directly, youtube@3dmusketeers.com, where I will do my best to help you get your printers back. Because you know what really sucks? Running out of filament. You know what sucks even worse? Not being able to run out of filament. We want to help you out here with Print Fix Friday. We have some interesting ones for you, and it seems that the theme this week is going to be all about layer woes. Anyways, guys, enjoy as we jump right into dealing with peak top layers that aren't so peak. First up, we have peak. It's just sideways. We got a print here from Discord member Devoid Colossus, who is going through some top layer issues. Now, I will say, rest of the print looks great, but we can see some gaps here in between the lines. That is indicative of under extrusion, or we might actually be printing too fast. We see towards the edging where it looks great, but in the middle, it doesn't look all that great. So it means that we might not be extruding enough material for the space that we're moving. He did a steps per millimeter check and it checked out perfect, like dead on steps per millimeter. And so this might be a good time to look at the slicer. A lot of slicers, and I believe this is a thing from Prusa, but I'm not 100% sure, where it sets the extrusion multiplier to 0.95 or 95% for a print. In Devoid's case here, this might not actually be the right thing that he's looking for, and you end up with gaps in between your lines. He might also have some back pressure, which would allow it when it's slowing down and doing that corner there or that edge to fill in the gap a little bit more, but I'm not 100% sure. I think the best thing right now is to look at tuning that extrusion multiplier percentage, maybe go up 1% or 2, but I would say otherwise, he's got a pretty good looking print here. Advice about PETG profile in images. So we got some pretty rough PETG parts here. It's not looking 100% great. Let's take a look at what we're doing. 230, 243, bed goes down from 85 to 75. Extrusion multiplier is really low. It shouldn't be that low. Fan is fine. Got no issues there. Lift height is good. There are a lot of settings here that I'm a little suspect about. Acceleration might be a little bit high, especially for your external perimeters, but it's okay. But our parts just, they don't look very good. We can see that the top surface is actually over extruding a little bit. We've got some stringing. Definitely if we look on the side profile here, this actually looks okay, but then it starts to get rough near the top. On the back side though, we definitely have some issues with this print, and we can see some buildup of the PETG. And because of that, we have to assume it's a Bowden printer, right? 230 for the first layer is a little cold. 243 is, in my opinion, for black PETG, still a little bit cold. If your bed temp going down to 75C after the first layer works, then that's fine. 0.89 on the extrusion multiplier, I would go to 0.95. We just talked about this in the previous fail hilariously, but in your particular case in this one, 0.95 is probably accurate. Now, the individual says, oh, it's only 0.05, but it's actually 5%. And that can equate to a fair bit, right? If you're trying to extrude 100 millimeters, you're now extruding, instead of 95, you're doing 89. And that 4 to 5 millimeter difference is gonna equate to differences in your prints. Fan always on is fine. Fan speed is good there. Disable the fan for the first 2 layers. That's good. Full fan speed at layer 3. We might need more cooling for this PETG. Some PETG likes a ton of cooling. Other PETG really doesn't like cooling at all. But the de-retraction distance being a negative number tells me that we've got a bit of a problem here. We never want that to be a negative number. Traditionally, it would be a positive number, if anything. And if you're having issues where it needs to be negative because you're either oozing or there's some back pressure or something like that, then we got to look at adjusting our retraction settings to being more friendly for the kind of work that you're doing. I do wish I knew what printer this was, but for a Bowden printer, you might want to try upping your retraction speed. 7 millimeters is actually a little high. I would maybe dump that down to like 4, maybe 5 millimeters, but the retraction speed put that up to like 60. The D-retraction, put it to like 30 and see if that helps. We might also be dealing with a damaged nozzle. Over time, nozzles can wear, especially if you're new to this and you might be running things like glow-in-the-dark filament through, which does degrade your nozzles. So be careful about that for those of you that are new. Glow-in-the-dark filaments, carbon fiber filaments, anything that is filled with anything other than, you know, PLA or PETG, ABS, whatever, if it is a filled filament, assume it is causing damage. Otherwise, like looking at this section, that's fine. There's really no issue with it. It's just like the top layers and some of the circular area. This to me says we don't have our retraction right. Up here tells me something else is wrong. We're using gyroid for some reason. I don't normally recommend gyroid infill unless it is the infill that you are looking for. While it is the tastiest infill when you're talking about chocolate, if you do want to see me interview Ellie, the chocolate printing goddess, if you will, we can card to that video right above for you. And we will be getting a cocoa press relatively soon. I just gotta complete that pre-order. So let me know, do you guys want to see a chocolate printer on the channel? My only concern with a chocolate printer is, one, the expense I'm going to have in the cores, but two, the fact that my ambient temperature is normally so high that the chocolate might not actually solidify. So let me know what you guys think down below. I don't know, maybe we'll get one sooner rather than later. But definitely, this looks like, yeah, see, we're not completing the ends of our lines. And the lines themselves look okay. I might try upping that extrusion multiplier back up to 0.95, because something here, it doesn't feel right. It might be a pressure advance problem, but our corners actually look pretty good. It's just that maybe there's not enough infill overlap percentage. This one could have a lot of particular problems wrong with it, and this is where I struggle sometimes, because what I think might be wrong might not be the actual answer. So I'd love to know what you guys think down in those comments below. I think we have a few things we need to work on. One of them being, let's return all the settings back to whatever the stock profile is. If this is an Ender style printer, use the Ender 3 profile. Just use it and try that. I know it's not ideal because it's not specifically your printer, but theoretically it should be good enough to give us kind of a baseline of what we're working with. I see a lot of things that have been modified, and I worry that they've made modifications that aren't necessarily the right modifications, and it's just compounded the error to make it worse and worse and worse. So they previously said that they had dried their filament. I'd like to show you what actual wet filament on a spool looks like. And no, before you start, this isn't a spool that was sold. This is a picture from the Polar 3D Discord group, where I've joined in because I do really like supporting made in America 3D filament manufacturing companies when we can. As a lot of you know, we love printed solid filament here and have been using their filament for years. And it is one of my favorite brands because it is affordable, it is made in America, and I happen to have toured there a few times, and I love the people. They have such an amazing culture within that company. If you want to see the last time where we went to Printed Solid and we toured, we'll card to that so you can take a look. And we will link to making our own custom filament at Printed Solid down below. It's a long video, but I think you're going to like it. It's pretty awesome. But one of the things that people say is it's wet filaments, wet filaments, wet filament. It's a very common thing when people claim it's wet filament. This is what actual wet filament looks like. So Polar 3D has been messing around with new colors, new materials, and part of that is you have to purge. This is a PETG purge, where they're purging out the material. And it's so wet you might think Cardi B is talking about it, and that's a terrible joke that I had to Google. You're welcome. But this is what like true wet PETG looks like. Polar 3D does not sell this filament. It is a purge thing that they're doing, but Mitch thought it was a cool photo. I completely agree, and I think it's a really cool thing to show what real damp PETG looks like when you are extruding it. Remember, in filament production lines, the die that they're extruding out of is roughly 3 to 5 millimeters. It can kind of depend on what they're doing and how fast they're pulling. The filament that comes out of it is much thicker. It is pulled to be the right kind of diameter and consistency that we are used to. And it is actually run through a water bath, but that water bath does not uptake enough water to do something like this. This is occurring inside of the raw plastic as is being purged out. I thought it was really cool. I thought you guys would enjoy it, and I hope that you do as well. If your filament looks like this, return it, but it shouldn't. I've never seen filament look like this before, but I just thought it was really cool to be able to show you guys. I would love to see this lit up with like LEDs using the PETG like a fiber optic. I think that would look super cool. Mitch, if you have some of this still, I kind of want to try that now. Send me the spool. I would love to do something fun with it. Printing bad, but only at lower layer heights. The one on the left is 0.2 and the one on the right is 0.15. I'm printing on a Cobra 2, which is from Anycubic, with Elegoo PLA+. Does anyone know what could be causing this? So man, we got some ugly looking layers. Great looking over here, looking like crap. And for 50 microns, that's not normal. But I don't think that the layer lines level being too small, 0.15 is not too small for a 0.4 millimeter nozzle. In fact, you can easily go down to 0.05, 50 microns, and still be okay. I think we have to look at our machine binding. This feels like it's a mechanical problem, because if you printed this 1 second, and it is exactly the same G-code, except for the layer height being modified, it should not look like this. It's not damp filament because the other one looks great. Like that other benchy looks phenomenal. Just, it's out of focus, but I'm working with what I got here, okay? I don't know. If everything else is the same and the only thing that we have is your baby stepping on the extruder not high enough and it's not able to get the detail that's needed, I'm gonna be calling, it's around the corners, and that's what tells me it's extrusion based, because like the straight lines look okay, but it's when the machine is making moves, we can see these kind of jagged 45-degree angled lines, which normally indicates that something is wrong with the extruder, with the hot end, with the nozzle. If this is a machine that you've had for a while, I would definitely check to see if there's any gunk built up in the PTFE tube for the printer. And because the Anycubic Cobra 2 is a Bowden printer, that PTFE tube goes all the way into the hot end. You'll want to pull that out, make sure it looks okay, and if it doesn't, just replace it. Quite frankly, just replace it. It's cheaper just to replace it and not have to deal with this. It's what I would recommend doing. Then we want to look to make sure that that nozzle's flowing right. When you look to start a print, extrude. Is the filament coming out dead straight, or is it curving at all? If it's curving, you could have a damaged nozzle. But again, I don't see it on the 0.2, so this is a really interesting one. Could it be a limitation of the machine? I don't know. It could also be that when we're running those finer layers, we're either overheating or not heating the plastic up enough. If your code for a 0.2 works perfectly, and you just change a 0.2 to a 0.15, it should also work perfectly. In fact, you should be able to run it faster. This one's gonna stump me, and I'm sure it's something really simple that I'm missing, but the lines tell me mechanical issue or extrusion-based issue. Let me know what you guys think down below. This could just be bad G-code. Honestly, it could just be bad G-code. There are so many stupid little things that can happen with 3D printing, and you know, sometimes it's good to just put the printer away, walk away overnight, and just come back and try it again. Because sometimes putting baby in the corner actually is what you're supposed to do. I don't care if you're not supposed to put baby in a corner. Sometimes you gotta put it in the corner to remind it who's boss. Next up, a fail from JK, designed from our Patreon Discord as well. I think you guys can kind of see a pattern here with these. We've got a honestly beautiful first layer, except for a couple little places. That is a perfect first layer on a textured build plate, but then it gets kind of crappy in some areas. My best guess here is that this is going to be just a dirty build plate. And I know that that seems like a really stupid thing. Like, grant this is a Voron, it shouldn't have, it happens. Dirty build plates are very common. If you accidentally touch it with your thumb or you touch it with your palm and you get a little bit of gunk on there, a little bit of oil from your hand, this is just not sticking. That is not the case of overextrusion. If it was overextrusion or you were too close, we would see a peak, and we don't see that. We see areas where it's lifting up. It's kind of grainy, but this is lifted up, right? And then the next layer is going down next to it. That's how that looks. So that tells me our bed is not clean. We clean the bed, it should solve the problem and get back to printing with purpose. That's what we like to do here on the channel, and this one is pretty simple. We like to clean our build plates in between prints with Windex. Real simple. You could use isopropyl alcohol if that's your kind of thing, and on certain build plate materials, you can use acetone. Please make sure that you do your research on that first, because like acetone on PEI, not friends with each other, especially the textured PEI. I like Windex. It seems to work well. It gives kind of a coating that PETG will release a little bit easier from, versus where PETG has a tendency to weld itself to PEI. Anyways, I think this is a clean bed issue. Pull off that build plate, go clean it with hot water and dish soap, and hold it like a vinyl record. From the edges, not from the top or the bottom. That way, when you put it back on the machine, you have not physically touched that build plate. A great way to test this is to flip the plate over, clean that side, and try that side, because you probably haven't touched that side. Honestly, though, you could probably just clean this alcohol and get away with it just fine. I know I've had that issue, and as we can see, his build plate's not perfect, but we're looking at what? That deviation is not that bad. 0.2, so 20 microns down to negative 0.109. So we're looking at like what? 0.13 millimeter of deviation. It's wiggly, and I'm not 100% certain why. I'm guessing this is the heater that's causing these issues, but that's a pretty darn flat build plate, and certainly the issues that they're running into problems don't appear to correlate with issues like this. But let's be real, a 0.13 millimeter deviation total on a build plate is not that bad, and if you are able to get this type of a height map, you can absolutely have your printer account for this kind of issue. I would recommend, if this wasn't done when it is hot, to do it when the plate is hot, but let the plate stabilize. Bring it up to 60, 70, 80 C, I don't care. But let the plate stabilize for 5, 10, 15 minutes. That way, because it's a big block of aluminum, let it stabilize so that it's not still kind of warping around. Another good thing that you can do is block any ambient draft from the machine as well. Things like air conditioning, fans in the room, ceiling fans, whatever it might be, can cause certain areas to get cool while other areas stay warm, and that can affect your bed level that you see here. But I would say 0.13 millimeters worth of deviation, that's not bad. It could be better, but that is more than fine when we consider traditionally how 3D printers can account for that kind of thing. Flexplate won't stick to bed. So I just got a Flexplate for my Photon Mono X2. Cleaned the bed well, tried printing the entire Flexplate and magnet base, both got stuck in the vat. I cleaned everything and tried using a Bison Extreme Grip double-sided tape. Same thing. Any advice would be much appreciated. The big thing with these flexible magnetic build plates is that you have to let them cure. The glue in it needs to sit and cure for a couple of days. Wham Bam, who if you use code Musketeers 2022, I'm fairly certain it's still 2022, will get you a nice sweet discount on your order. They say 72 hours. You put some weight on it, leave it for 72 hours, and as long as your build plate is clean and you stuck it on there with like a nice, good, clean surface, it should stick on just fine. I don't think this individual did that. Let's take a look. Thank you, everyone. I didn't let it cure. There you go. Sucks. I read a review on Amazon saying the adhesive didn't work well and that they used tape, and it worked. So I kind of followed them blindly. This was obviously me being overly impatient. Yeah, bit of a bummer because there's not much you can do to fix this. I say get a new plate, try again. This has been a good lesson learned that didn't cost you a bunch other than your time. The other thing to note, if you put magnetic plates on your printers, make sure that you print the little piece for the sensor for the Z, because on a lot of these printers, they're not designed to have the magnetic flex plates on the resin printers. So if you try that, you'll slam your new bed into your screen. So don't do that. And always wear gloves like this person is, because remember, resin is toxic. We haven't had a good resin is toxic in a while. It's good that we have them every now and then. Gotta remind you that resin is toxic, because if I don't remind you that resin is toxic, the editors don't eat because they get paid by the hour. But you know who doesn't get paid by the hour? Maybe they do. The awesome people right next to me, whose names are at the $5 tier and higher. Thank you for all that you do in making these videos possible, because without you guys, this kind of stuff would not be affordable to us to do. Thank you, and if you do want to join again, links down below. More PrintFix Friday action right below me, and right next to me will be the bamboo log video that a lot of you waited for, and not a lot of you watched. I can see my metrics. I know how this works. Anyway, stay safe out there. Don't forget to call your loved ones. Leave a like, get subscribed, and leave a comment. And as always, keep making awesome. Have a good one. Who did WAP? I don't... Cardi B. Okay.